Wastewater treatment needs are enormous.
Wastewater treatment will play an incredibly important role in accommodating future water demand. Conventional wastewater treatment consists of 3 steps: primary treatment, biological treatment, and solids-liquid separation. The crucial part of the process is the solids-liquid separation. With a conventional sedimentation process, there is often insufficient removal of bacteria and suspended solids. For example, in 1 liter of typical secondary effluent, there are 10 million bacteria, which can be difficult to remove.
The solution is here.
Membrane technology has led to a new revolutionary concept in wastewater treatment. Membranes act as a barrier to bacteria and suspended solids to produce a low turbidity water with very low bacteria counts. Membrane bioreactors, simply called MBRs, offer the optimum solution. The membrane modules are submerged in the activated sludge to combine the biological step and the solids-liquid separation into a single process. Since the membrane acts as a barrier, this improves the effluent quality. Also, the membrane barrier eliminates the secondary clarifier and allows the activated sludge to be more concentrated. This reduces the volume requirement for biological tanks, thus saving space and money. When compared to conventional wastewater treatment, it's clear that MBR treatment is far superior. Due to the tough environment in which the membranes are operated, membrane module design is of the utmost importance for successful operation of the MBR. The membranes extract clean water from the sludge, leading to dewatering of the activated sludge around the membrane module. This concentrates the solids surrounding the module and can lead to plugging of the module. An important feature of a good MBR system is a reliable method of flushing the solid matter out of the module to avoid clogging and sludging problems. Additionally, the module design needs to be able to handle hairs and fibrous material.
The Puron MBR solution. Naturally.
The Puron MBR technology consists of hollow fiber membranes arranged in bundles. After biological treatment, the treated water passes from the outside of the fibers to the inside. The membrane, with a pore size of approximately 0.05 micron, provides a barrier to suspended solids, including bacteria. The fibers are fixed only at the bottom and can move freely along their entire length. The top ends of the fibers are sealed. During normal operation, a vacuum is applied to the bottom of the bundles and water is sucked through the wall of the membrane. The solids remain on the outside of the module and clean water is drawn out through the inside of the hollow fibers into a single header. Aeration at the center of each bundle ensures that all solids, such as hairs, fibrous material, and sludge, are flushed out of the module.
Puron MBR technology solves the problem of clogging.
Hairs and fibrous material can be a big problem for other MBR designs, especially for hollow fiber modules that use a double header design. Double header modules have a serious disadvantage in comparison with the Puron design. When hairs and fibrous material within the sludge enter the membrane module, they float to the top due to the air scouring. The upper header acts like a barrier or screen, leading to clogging. This reduces available membrane filtration area, which affects system performance. Additionally, the clogging leads to higher mechanical stress on the membranes, which causes damage and will shorten membrane life. To minimize these issues, double header products require very fine pre-screening, leading to higher capital and operating costs. Puron technology provides a simple solution. It's the single header design. The Puron single header allows hairs, sludge, and fibrous material to be easily removed from the top of the module by simple intermittent air scouring, eliminating the risk of clogging.
What about sludging problems?
Another issue with many MBR modules is sludging. Sludging occurs in dead zones where the air does not reach the membranes. This is often the case for double header modules, as they mostly supply the air from below the bottom header. When the air is supplied below the bottom header, much of the air bubbles around the outside of the membrane module and does not reach the interior fibers of the module. This allows sludge to settle, leading to fouling and sludging of the module. A unique way to combat this issue is the central aeration system of the Puron technology. Central aeration injects the air in the middle of the fiber bundles, right where it is needed to avoid sludging. In summary, the unique single header and central aeration in Puron modules patented by KMS allow for reliable, trouble-free operation. The individual fiber bundles are incorporated into a simple modular design to create the full-scale membrane module. The bundles are arranged in rows, with the bottom headers being connected together. Several rows are then mounted in a stainless steel frame to create the module. The Puron modules can be submerged right into the biological treatment tank below the liquid level, or they can be placed in a separate membrane tank. The advantage of a separate membrane tank is that the biological process and the membrane process can be optimized individually. The mixed liquor is recirculated back from the membrane chamber to the aerobic or anoxic zones of the biological process. At the municipal wastewater treatment plant in Simmerath, Germany, a Puron MBR system has been in operation since 2003. The system performance is excellent, and the membranes are still in perfect condition. It's easy to see that the Puron MBR technology has many advantages.
High effluent quality. Footprint.
Puron MBR systems need only about half the footprint of a conventional wastewater treatment plant. This provides a great capital cost savings, whether for a plant upgrade, a plant expansion, or for a new plant. The capacity of an existing plant, for example, can be increased without requiring additional footprint.
Long membrane life.
The Puron hollow fiber membranes are reinforced with a multitude of very fine, solid fibers woven into a hollow tubular configuration. The membrane is then cast onto this structure, which makes the membrane extremely strong and gives it a very long membrane life. Automotive tires are reinforced in a similar manner to give them the extraordinary strength and lifetime that they enjoy.
Low energy consumption.
Central aeration optimizes air usage by putting the air where it is needed. This dramatically lowers the energy needed for air scouring by as much as 25 to 50% of the energy required for other MBR modules.
High and stable flux.
The Puron single header design results in reliable operation at high and stable flux rates.
Simple pre-screening.
Simple pre-screening reduces investment costs. The Puron single header design and central aeration allows for selection of economical types of pre-screen.
The best choice for any MBR application.
Puron MBR modules are the best choice in any MBR application. They are available in standard sizes of 235 square meters and 500 square meters, or can be customized to retrofit any existing conventional system. If a customer is dissatisfied with his existing MBR modules, the improved Puron design can also be used to retrofit earlier generation double-header systems to improve operating costs and reliability.
MBR is used in many industries.
MBR is not only used for municipal wastewater, it is used in many industries. Puron MBR solves many problems in industry, especially where large amounts of water are used and reuse is required, or where space is limited. For example, the Sobelgrau Malting Company in Belgium needed to double production, but they did not have the space to double conventional wastewater treatment. The installed MBR system treats 2,000 cubic meters per day with 16 Puron modules, a total of 8,000 square meters of membrane area. This Puron MBR was commissioned in November 2004. Not only did the Puron MBR system meet production needs, but produced water that was over 10 times better than the effluent produced with the old conventional plant.
MBR passes stringent regulations.
There is a tremendous need for the Puron MBR technology. The need to treat wastewater to protect our freshwater supply and to recover water for reuse grows daily. Puron MBR technology from KOCH Membrane Systems is here to help you solve all your wastewater treatment challenges.